Uh, I hope you understand me, and this is it. Let's just see how it's going. Um, let's do a bunch of like Python. See, and I always like to start Python with a lot of problem solving, but a very little amount of theory. So this is what I use in general to learn most of my Python. It's called like Python Workbook. Uh, by Anthology. This is like a site. The guy is like fucking amazing. Uh, let's see if he has an updated like version of it. Um, functional programming. This is awesome. Like, okay, I don't think he updated it very much, but anyways, it works. So this guy has like the hardest problems there is. If you could like go through all the 6 chapters in his book and you could solve all the problems, then you have a very good grip on Python and programming in general. So let's just go. I hope you can see the background. Fucking A. So yeah, okay. I hope you can see the background. Um, so like just if you already have Python installed, you just need to type Python, and most of the laptops these days are coming with Python installed. And I think as you can see, the version is like Python 3.7.4. So we should go for Python as well, 3.7.4 as well, or something like Python 3 in general. So I already have Python 3 installed, which is like if I type Python 3, yeah, we have like Python 3.9.8, which is the latest version of Python. So let's go with that. Um, so it's pretty easy. The prompt like this is so you can have your own Python source files as well, which are represented by .py. We'll get into that later, but first, to get a feel of the programming language, it's always a nice idea to play with the terminal. So just like type a number, it works, and like do basic like arithmetic. 4 plus 2 is 6, and 4 by 2 is 2.0. Hey, that's nice. See, what used to happen earlier was in Python 2, like let's see, the division operation used to be uh, integer division. 4 by 2 is 2, not 2.0. And like if I say 3 by 2, it used to be 1, but it's supposed to be 1.5. For that to happen, you need to specify the type, or you need to specify the type as 3.0 or something, so as to say that you want a decimal answer. So then you get 1.5. But with the new Python 3, so what happened is division in general turned out to be a fractional division, which is how real mathematics works. So that's really nice. I'm so glad. So yeah. So the first problem here is like open the Python interpreter and like use it to find the value of 2 plus 3. Okay, let's do that. 2 plus 3 is 5. That works. Great. So running Python scripts. So this is when you graduate out of the terminal and you make your own Python scripts. So let's see. Mhm. Let's create a directory Python play. Good. Let's get into that documentary Python play, and let's create a file. Mm. Let's open text editor. I'll use Emacs in general, so let's go for that. Mm. Okay, so this is it. Okay, this is crazy, but let's just trust me. It's one of the best things out there. So let's create a file, hello.py, as the guy says. Yeah. So let's just write print. Uh, Print is a function, so that's why like the brackets open, which takes one input, which is the stuff that you want printed. So if you print like hello.world, so hello.world historically has been the, so we'll save it, So this is supposed to be the first program that you write in any programming language. So let's see. So there is a hello.py. So you need to do Python. So in my case, I have Python 2 and 3 both installed. So I'll just say, type Python 3 instead of Python, because my default installation is Python 2. So hello.py, there you go. Like, it prints hello world, and that's how it works. So let's go for the next one, data types. So every programming language deals with a bunch of data types, like basic data types. We call them primitive data types. It's like one of those data types the language gives to you. Like, so one of the basic like data types the language gives you is numbers, like integers, specifically speaking. So yeah, say 1 plus 2 is equal to 3, and Python is also very good at holding large numbers. So uh, I don't know if you ever did this in school. If you compute 2 power 3 or 2 power 10, it very quickly it escalates into, so this star double star is, so one star is like for multiplication, and double star is a power function. So it's like 2 to the power of 10. So it's 1024, which is easy. But as you keep climbing, this gets like very long and complicated. So Python provides you with long form integers, so that it can easily store like a humongously large numbers. So, and normally it ends with the letter capital L. So let's see this. So it's a huge number. It didn't end with L. So let's make it even bigger. It didn't end with L. That's crazy. So yeah, maybe it's only this Python like 2 which the numbers end with like L. So this is taking a bit longer, and let's see if this one ends with L. Maybe like numbers don't end with L anymore. Earlier, like even 10-digit numbers used to end with a L, which signifying the Python stores them as long integers. Okay, so let's go now. Probably they put that as a default like phase. So Python has like floating point numbers. Uh, so these are like just rational numbers really. So like fractional numbers. So yeah, if you just like add 1.2 plus 2.3, it just gives the right answer. Yeah. So Python also has strings, which is like the primitive objects. Every language gives you strings and characters, but like Python starts with strings. So hello world, bam, like hello world. And like so there are like a bunch of things you can do with strings. There is stuff that you call like, say, there is this thing called backslash, you call this. You can find it on your keyboard. If you put like backslash and t or backslash n, it, it has a different meaning. These are called like, I think, like escape characters or something. So I mean, it's this backslash t means a tab. So it is like four spaces between whatever. Like if you put that, like you get four spaces. So like say hello world, my name is like Dinesh. So like hello world Dinesh, and if you print it, you'll see a space, like a tab space between like hello world and Dinesh. Let's print it out. See, that's right. So let's try the n thing. So if you try type n means new line. So the name Dinesh will print on a new line. Okay. So let's just like print it and see how it works out. Great. So hello world and Dinesh. Okay, so now see, the thing is like these operations like plus, they also kind of like, they're very generic operations in Python. They also work on strings. So we can do this. So hello plus world, that's hello world. So just like probably let's give it a space. You can do bam, hello world. So you can also do all kinds of things. So see, the trick is to follow me like real time if you can, like to just keep the video running in a small like block and just do these things yourself. Like download Python, it's very easy. Go to python.org and you can download. It's just a small like file exe, and double click and install whatever. Yeah. So this is like if you follow it up, like your fingers remember these things. Like muscle memory is extremely important when it comes to programming as well, just like in anything else. So just keep typing this stuff up as you go, as I go along, right? So like hello into 3 is like it prints 3 hellos. Like let's give it a space so that like it makes more sense. So hello, hello, hello. Okay, so let's just see. So print, let's do this. Print is equal to into 40. Oh, this is awesome. Prints a line. That's great. Let's just do this. Bam. This is nice. So you can print pretty much anything, really. So write a program. See, over time, like we'll probably like end up using this, and like we'll write a bunch of like insanely awesome programs. So we can use this like as you can understand, we can make stars, pyramids, and whatnot by lining all these dots and all this stuff line by line. It can be pretty interesting. So like let's give them a shot like in a bit. Yeah. So let's go. So what's the next thing? Let's see if we can combine also these things in a arithmetic fashion. No, they don't work well. So you whatever you gotta do inside like the print function. So blah 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 10 plus. Okay, let's see if this works out. Awesome. See, like you get like 10 spaces in the beginning. So nice. So let's do this. Yep. So let's be stupid and like do something crazy. Uh, so we'll put like 10 spaces before and like 10 spaces after. Yeah, that works out. So let's just do this. Let's just put like one dot and like 10 spaces and 10 everything. So overall you have like 21, like place for 21, and then you just add uh, a nice little n at the end, and then you add plus, and then like see what you do is you just copy paste this stuff up and put this here, and then you can just do wild shit, right? So you can just make, I don't know, 3, and like if you put 3, see the whole thing is like 10 plus 10 plus 1 is 21, right? You minus 3 out of it, so it is like 18. So you can just do 9 and 9, 9, and you can do this, and instead of 3 let's go for 5. And if you go for 5, 21 minus 5 is like 16, so you just put 8, 8, and 8. So you can do a bunch of interesting things if you keep on going like this. So like to do the same thing, you know, like decreasing, like we have this concept called like for loops and while loops, where you don't have to like type out all this stuff to get this, you know, like it's a small little pyramid, like small little triangle that you're making. So I'll teach you as we go along. These things can be pretty interesting. Anyways, so let's get on with the next thing. So there is this another function that the strings use called length. Like it goes by length, and you can get like length of any string. So like my name is Dinesh Padishetty. Let's get the length of that thing. Yeah, it's 16. That's awesome. So see what happens like when you try to see, imagine like you want to hold a string which has multiple lines, say like Dinesh Padishetty, and if you want to like, you know, if you want to like press enter and go to the next line, it just doesn't work out like that. This is only to hold like one line strings, this quotes, right? The single quotes. So we need to have like this 3 quotes, and that then like Python interpreter allows you to hold like multiple strings, right? Whatever, you can print some like blah blah blah, and you put three then it works out. See what it does, like when it formats, it puts a backslash n in between, right? Like see here. So that's what like this going to the next line means, like backslash n. But once you print it, it will print just like you want it, right? So I hope you're understanding this. So let's just go. Mm, so here they're explaining the same thing that we explained, like the backslash n and backslash t for tabs, and there are several characters like this. You can like find a reference of all the backspace characters for Python or any programming language. Actually, even C has it. Every programming language has it in a way. So yeah, let's go for the next primitive type of data type. So this primitive data type is like to hold a collection of things. Like say it's a list. It's like a list of things. So this is for like a list of strings. You just put the element and like put a comma, and then just keep going. And you can hold like pretty much any amount of it. So just ax is equal to. So you can also use the length function here. So length of x is 3. That's awesome. So if you want to find the first element, see in computer science, the counting starts from 0. The first thing is 0, like x of 0. The first element is 0, not 1. So x0, and then x1, and then x2, right? It's the third element. So then the last, I think like the, not the last. So then the next thing is like a tuple. A tuple is so basically, Python has another data type. It's called a tuple. It's for representing like fixed width of things. So the difference between a list, so x, so let's just like put y is equal to 1, 2. This is to represent like, so the length of the y will never change. So the difference between x and y, the list and tuple is, see you can always add another element to the x. Say x is equal to, right, a comma b comma c. So you can say x of 3 is equal to, I don't know, d, and you can, oh, you can't. Oh, you can't add it. That's insane. So, but like you can. So basically, there is this function, push. You can add like another element, right? So let's see. Uh, Push pop. Append. Sorry. Append. So yeah, you can append another element to the end. So if you type for x now, it increased from length of 3 to 4. So this is something that you can never do with a pair. So or a tuple. So if a tuple is 1 comma 2, right, you can change the elements like say but you can never increase the length of it started with 2 elements, it will always gonna be 2 elements, right? Okay. So these kind of things are useful in representing dimensional things, right? So if you want to represent two-dimensional points in a coordinate plane x comma y, right, for math nerds out there or any just basic math, you can just represent like points in a plane using this, or points in 3 dimension. Like it's insane. Like the tuples can be very useful if you're representing like n-dimensional like programming. It's awesome. So let's leave it at that. Like let's just like see, it's very similar. Like you want to get access to things and you want to change the first element from 1 to 3. You just, oh, tuple objects does not support item assignment. So yeah, you probably can't even like change uh thing. It's very fixed. So you can't, like, they're immutable. The meaning of immutable is you just can't change them. Once you get them fixed, like, they're fixed. Let's see if we can. Oh, that's nice. This works. Okay, this is fun. Anyways, so point, right? Let's just see how it looks when you print them. Yeah, it looks like a point basically. It's also to assign multiple tuple values at once. So you can also do this like crazy assignment where, say, like just like let's see, the point is 1 comma 2 comma 3, right? So you can assign x comma y comma z is equal to point, right? Then the x will be attached. It's like pattern matching, right? You know what's happening. X will be the one, y will be 2, and z will be 3. So this is one way of assigning like elements, and this only works with like tuples. Okay, it doesn't work with lists because it can get insane. Lists can be changed all the time right from a. So let's just see if it works for lists. So x comma y is equal to right of so, oh shit, we called the thing x, so you can't do that again. So just like say list is ls, right? 1 comma 2. Let's see if it works. So let's see x comma y is equal to ls. Does it work? Jesus, I think it works. Like x is equal to 1. Oh shit, it works. It works with lists as well. That's awesome. But see, lists has a chance. So like x comma y comma z is equal to ls. Okay, it gives a value error. So if you can match the number of elements with the number of variables on the left side, it works with lists as well. See, never say something doesn't work in programming because it can surprise you. You should always type it out and like test it out. Otherwise, you can't say what works and what doesn't work. That's the good thing about programming. You get instant feedback. So the last data type is not last. So like the last type of collection data type is a dictionary. So dictionary, as you can see, is just like it's like key value pairs. So it's like, say if you're like trying to describe a person, right? So you can say like the name of the person is Dinesh, and we can say the email. No, you can say the age is 28. So you can say things like this, right? You have a key, right, and you have like the value. So you can talk about things like that with a dictionary. So if like this is just like named lists. So if name of a person is Dinesh. So name of this is similar to lists in a way. Name and person's age is 28. So the crazy thing is you can put all these like dictionaries in lists. So like let's see, a list of people, right, is equal to, so you can just put Dinesh, which is me, name Dinesh, and age 28, right? So you can make another dictionary of like some other guy, name is, I don't know, John, right? Right, John. And what's John's age? Let's say John is 30 years old. So yeah, so a list of people. So these are the primitive data types. You can use lists, you can combine lists with this, lists with dictionaries, and dictionaries with all those kinds of things, right? So like what is the name of the first person? So like what is the, like if you want to get the first dictionary or for like first person, just like see like the first person is name is Dinesh, and you can just inside the dictionary, if you want to get the name of the person, name of the first person is like Dinesh, and age of the first person is 28. So like if you want to go to the second person, this is how you access the second person, and the age of the second person is 30, and the name of the second person is John. So it's that simple. So next we get to this data type called a set. um, a set, as you might have learned from like mathematics, is a list of unique things, right? You can't have the same element twice in a set. So if I put like 1 2 3 2 1 in a set, the unique elements are only 1 2 and 3. 2 is repeated twice and 1 is repeated twice, so it will remove it. So if you put it in like curly brackets, curly braces, you'll get a set in Python. So yeah, if you ask for x, it will only give you 1 2 3. It will remove the last two elements because they are not unique. So this is nice. And Python also has a Boolean type. A Boolean type is nothing but it's like true or false. It's like you learn in mathematics. So yeah, x is equal to true, right? Print x true, and x is equal, y is equal to false, right? So I is equal to false. So you can do all kinds of interesting things, like Boolean algebra you might have learned in your mathematics. So x or y is equal to, oh shit, maybe I can just say like x or y. So true or false is true, x and y is like false obviously, and not x, not x, x is like true, so like not x should be false. Ah, come on. Okay, maybe I need to write, spell it out. Not x is false, so not y is true. So that's all. And also there's like one last special type, it's called none. It's like when nothing is there, you know, like x is called none, so you can just print x. So it's basically like a placeholder for things. So now you know the most common data structures of Python. They are very simple, like, but as we went through there might be surprises. Like for example, in lists that we discovered, you can assign them same like pairs. So you might be discovering surprises once you start combining these primitive types and you use them a lot. So that's all for now. And yeah, so and also like let's just go through variables. We've already been using variables really, right? A variable is nothing like but a name. Say x is equal to 5, or just say number is equal to 5. This number, the name number, is called a variable because it holds the value of the number 5 for you. So anything like that holds things for you is a variable. And Python variables like don't have a type. As I told you, they're just placeholders which can hold any type of values. So it's important to know the difference between variables and strings. Okay, yeah, sure. So like a variable is just a name, but a string, it comes with like quotes, right? See, it comes with like quotes. Otherwise, it's a name. It's a variable. So yeah, that's all for now. And we've already, I think, used the functions. See, whenever you use a function, you put something in brackets. See, like print is a function that we have been using for a while, and like len is a function, right? So this is a function, like um, and functions can be of various types. See, like this is like a basic function. You apply the function to like whatever variable you have, and or value you have. But functions can also be like built-in functions. Like for example, the plus is a built-in function. You can't have this obviously, but like 5 plus 2 is 7. But maybe we can use, so the arithmetic operators are like very built-in functions. So int is like another function, right? You convert any string into an integer if it can be converted. So string, you can convert like an integer into string. These are useful as time goes by. As you will see, if you want to combine like 5 plus 2, it doesn't work like that because 2 is a string, but you can convert that into an integer with using this int function that we discovered earlier. So yeah, this can get like pretty useful as things go on. And there is an example like it's discussed here where we're counting the number of digits in a number. Look, it's very easy, right? So if x is equal to say 2 power, like let's take something long, 2 power 100, right? So x is like a very long number. So how do you count the number of digits? So there are other ways to do this, like more efficient, like algorithmic ways to do this. But if you just like knew whatever I told you in the last I don't know, like 1 hour or half an hour, then there is an easier way to do this. So the sneaky way to do this, so first you need to convert like the number into a string, right? And then you use the length function on the string to get to the number of digits, which is like the dumbest way but also the easiest way. So the length of the string is 31, so the number of digits is 31, right? So I think that's what they'll do here. Yeah, that's exactly what they did. So yeah, that's like crazy, but it works. It's just a hack that works. So let's see. 31 digits and 3 not 2 digits. Let's see if there is a pattern as we keep increasing like the like let's start with like 2 power 1, right? 1. It seems neat. 2 power 10 is 4. 2 power 100 is 31. Let's see if there is a pattern. See, I have like more mathematical bent of mind, like, and I want to try dumb things like this to see if there is a pattern. So 3011, 30103. See what's happening here. That's insane. Ah, so it's also increasing a digit. See, the pattern is very simple here. So, so we learned this when we were younger. So to calculate the number of digits in like 2 power or any power, like a power b, a to the power of b. So what you do is you multiply the b, which is the power. So let's just say 10,000, right? 10,000, like you're trying to find the amount of digits in 2 power 10,000. So what you do is you multiply 10,000 with log of 2, log of 2, and you add the number 1, uh, right? Log is not defined, so I think it's ln, I don't know, log 10. Does Python have like a log 10? Let's see if Python has like, see, log function in Python. Let's see. It's dumb, but like let's just see. I think like the math module should have some kind of, so yeah, there is this like math module that Python gives where you can get a log function. So okay, let's see. So math.log. Let's just see. Uh, so you need to import the modules if you want to use them, the default modules. So let's just use. So just I will get to this later, the modules. Python provides a lot of libraries for like the math library for you to use a bunch of functions. So what you do is 10,000 into math.log 2, and you just do plus 1, right? 2 power 10,000. This is the 2 power 10,000 one. Ah, not log. I think like log 2 base 10. That's what, like the base 10 logarithm is what we want. See, it's like 3011, right? So that is the formula. Like, and if you put like, I don't know, if you convert that into an integer, that's the answer you're supposed to get. This is the formula for like finding the number of digits in 2 power, I don't know, anything, or a power b, 2 power 10,000. Let's just see for 1,000, right? So what do you do for 1,000, right? So you just like multiply 1,000 into log 2 base 10 plus 1. So that is 302, and that's exactly what you got here. So that's just like it's a nice like fun little thing to verify. Anyways, so and and as a matter of fact, instead of using this like length string function, the algorithmically safe and sound way to find the number of digits in any amount of any a to the power b would be to use this formula, because at some point it gets very difficult for the Python processor to calculate. Say 2,000, 2 power 10,000, it calculated very easily. So 2 power 100,000, it's a little get difficult. And 2 power a million, see, it's taking a bit of time to print the answer, right? But instead, if you just like know the formula, it prints faster. The answer you get the faster. So these are like algorithmic complexity and all those things that you can learn later. See, this is the same thing. If you want to like find out the number of digits, right? It's 301030. It's very fast using the formula. Mathematical formula is like so freaking fast. So instead of that, let's just say, we are using this, right? Let's find the length and like verify if it's true. See, this is taking a second, right? But the formula above just doesn't even take any time. It's very instant. The that's the importance of using the correct like algorithm for finding a solution to a problem. That makes all the difference as the input amount increases, like say 2 power 100,000. See, like if you go one more step, like 2 power 10 million, this takes a lot of time and it might not even like print the answer, but the above formula works much better. See, it takes like much like a little bit longer time, because the algorithm, the string and like length, it's just a hack. It's it's not that useful. See, like it's already taken like 5 seconds, I don't know, like it might take a while, right? But if I know for a fact that if I apply the above formula, that like 10 million into log of 2 base 10 plus 1, it gives the answer just like that. Okay, let's just stop this. Like this is torture. It's irritating the computer. So it's just stuck there. Shall we wait for a second? Maybe not. Screw it. So instead, like if I try with this thing, like 10 million, just like that, it gives the answer. Okay. So let's end this with this example, and we'll regroup later. Yeah. Have a nice time, and like go through this link. Yeah. And like go through this link and see if you can like finish up. Have fun. Bye.